Morning, Chair.
Morning.
Good morning, Miss Rina.
Morning.
Chair,
Yes.
remember when I messaged you about the work that
Yeah.
how to do? I think I didn't read I think I didn't read the instruction properly, or my computer glitched or something. Because when the first time I read it, I didn't see that you only said to do question 1, 2, and 4. So I did the whole thing.
Oh, okay.
Yes. So I had no idea what a convex lens and all was.
Okay. Yeah, only 1, 2, and 4.
Uh, One direction.
Okay, good morning, everyone. I'll just quickly take attendance, then we will start, okay? Okay, Isaac? Isaac, not here. Oh, Isaac, are you here? No, not here. Okay, Isabel?
Here, Chair.
Abigail? Okay. Carlos? Carlos not here. Elijah? Elijah?
Here, sorry, my mic was muted.
Kavishka?
Here, Chair.
Ricardo?
Here, Chair.
Celeste? Celeste is here. Okay. Pooja. Okay. Sureka.
Here, Cha.
Okay. Aaron Look. Not here. Zarib. Sorry, that's not here. Michelle. Zarib, are you here? No, Michelle is not here. Malcolm. Not here. Jared.
Here, Cha.
Judith. Judith is not here. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. Let me just post in the group. Judith is here. Okay, just a second. Okay, Isaac is here. Okay, let's start. Would you all like to start with workbook or the light questions on light?
Workbook.
Workbook, okay. Okay, let's start with workbook. We were supposed to do 77, 78, and 81, correct? Okay, so let's start. So 77, page 77 of your workbook. Okay, explaining density 8.9. Circle the correct word or phrase in each bold pair in the paragraph below. Who wants to try?
Is it bigger?
Okay, read the whole thing with your answer.
Wait, Cha. Let me just. The density of a solid is bigger than the density of liquid. This is because the particles in a are not arranged in a regular pattern.
Okay.
The density of a gas is much smaller than the density of liquid because the particles in gas are much further apart than they are in a liquid.
Correct. Okay, everyone got that? Okay, let's continue. So basically what the paragraph says is that density in solid is the biggest, density in gas is the smallest. Why? Because of the arrangement of their particles. Solid, they're more compact. Gas, they are very much further apart. Okay, next one. Submarines and fish can change their density so that they can move up and down in the ocean. A submarine uses a tank around the outside of the inner tank where people live. The outer tank can be flooded or can have air pumped into it. Okay, so basically if they add in water, it will become heavier, so it will sink. If they let air come in, that means it will float because now it's lighter, density is lesser. Okay, So that's the picture. Explain how these tanks are used to submerge the submarine. Use ideas about density in your answer. Who wants to
You can
try?
try.
Yeah.
When you pump air into the outer tank or flood it, you increase the mass and volume of the tank. When this happens, the density of the tank is higher than the density of the water, so therefore the tank sinks.
Sorry, can you repeat that again?
The whole thing, Ajahn.
Yes.
Okay, when you pump air into the outer tank or flood it, you increase the mass and volume of the tank. When this happens, the density of the tank is higher than the density of the water, so therefore the tank sinks.
If I pump what into the tank, it will sink.
If you pump air and flood it, like the question says, if the outer tank can be flooded or have air pumped into it,
Okay, but if I pump air into it, wouldn't the density be lesser, which means we'll make it float?
air. So
Because air has
what?
smaller density.
Doesn't air have exit pressure? So
Correct, but compared to air and water, water has more mass and pressure.
so I just cancel out the flooding. I just cancel out the pumping in the air part lah.
You put there water. So it's actually when you pump water into the tank, then because water, when you fill the tank with water, this will increase the mass of the whole submarine because now there's more water. So the density of the whole submarine will now increase. So because the density is higher and greater than the water outside of it, greater than the ocean water, so the submarine will sink, will submerge. When you add in air, that will make it lighter than the density of the water, so the submarine will move upwards.
So is it because it exerts pressure upwards?
Sorry?
Is it because it exerts pressure upwards?
No, because the air is lighter,
Oh, okay.
so it will move upwards. Okay, so I'll just repeat that one more time. When a submarine's tank filled with water, this will increase the mass of the submarine and therefore the density as well. So that when the density is greater than that of the water surrounding the submarine, it will submerge. So basically you're making when you add water to the submarine, you're just making the submarine heavier. So the heavier it is, the density is greater, it will sink. When you remove the water, when you pump in air, then you're making the submarine lighter. So when it's lighter and less denser, it will float, it will move upwards. Okay, B, explain how these tanks are used to surface the submarine. Use ideas about density in your answer. So now that just now was submerged, now surface. So basically it's the air, so air is now pumped because you want it to come to the surface. Air is pumped into the tank, water is pumped out. Air is less dense than water, and so the submarine's mass and density decreases until it is less than that of the water, and then it will move, it will surface up lah. So A is talking about how to submerge it. So you talk about adding in water and the density will be higher, it will sink. B, they're asking about when it surfaces, when it floats, go up. So you pump in air instead of water, and then because air is less dense than water, the submarine's mass and density will decrease until it is less than the density of water, and then it will surface up.
Yeah.
Yes.
So I wrote these tanks can control the mass and the volume of the submarine depending on how much gas or liquid you put into it. If the density of the submarine is lower than the water's density, it'll float. Can
Correct. Then you add in by saying, for this to happen, you need to pump air into the tank. To answer the question of how to surface the submarine. Okay, next one. Blocks of 4 different materials are in a tank of water. All the blocks have the same volume. Okay, they have the same volume. And remember, density is mass over volume. Right, true or false? Okay, Abigail, the first one. Q is the least dense and S is the most dense.
I cannot really see the the picture properly, like the wordings on it.
Can you see the picture?
Yeah, but I cannot see like the,
Alphabet.
yeah,
Okay, the first one on the left is Q. The
okay,
second one beside Q is R.
okay,
The one the most bottom is S.
okay,
And the most far right is P.
okay.
Okay, so the first one, Q is the least dense and S is the most dense. True or false?
False. True.
True. Or
False.
okay, which one is the most dense? The one that sinks the most or floats the most?
Sinks.
Correct. So the most dense will be which block?
S.
Correct. The one that is least dense will float the most or sink the most?
Float.
Float the most. So which one floats the most?
Q. I mean, yeah. Wait. R.
No. Which one floats the most? Which one is on the surface of the water more?
Oh, the last block.
Correct. P. So statement A, Q is the least dense, S is the most dense. True or false?
False.
False. Okay. B, Isabel. S is the densest and R is the second densest.
False.
False. Which one is the second densest?
Q.
Q. Okay. Third, Q is less dense than P. True or false? Jared.
False, sir.
False. D, R is more dense than P. Judith.
Pardon, sir?
Is R more dense than P?
I didn't do the question, so I was confused.
Confused with? What are you confused about?
Give me a moment, sir.
R is more dense than P. Judith, is it true or false?
True.
True. And the last one, none of the blocks is less dense than water. Celeste? True or false? None of the blocks is less dense than water. You said false, correct. Okay. Okay, did you all do part E?
No, sir.
No?
No, sir, because it was very hard.
I
Okay.
never do part E, sir. We usually have to do until section 3 only.
Okay. Just give me a moment. Okay, anyone has any questions so far?
No, sir.
Yeah, sir. Sir.
Yeah.
Sir, I just wanted to ask, sir, you know those tanks in question 2, right? If you pump the whole thing with air, the thing would, the whole submarine should float, right?
Yes.
But if you pump like halfway water, halfway gas, you'll just like float on the above the surface of the water, right?
Above the surface or maybe half in the middle. So not fully submerged lah into the water.
So the question asked why I said because gas is lighter than the submarine lah.
gas is less dense than water. So that will cause the submarine's mass to also be lighter.
Okay, teacher.
It's like, let's say you have a balloon and then you fill the balloon with air. You make it lighter, it can rise up. But let's say you take the balloon and fill it with water, it will be much more difficult to try and push it up or bounce it up in the air. It's the same thing, because when you add water to it, the balloon becomes heavier. So it's more dense compared to when you put air into it. When you blow air into the balloon, you can bounce it because air is light. So it causes the balloon to have less density.
Okay, teacher.
Okay, let's look at the next page, page 78. Read the information in the box, then answer the questions below. Okay, Ricardo, can you read for us the passage, please?
Okay, teacher.
We are on page 78, everyone. Okay, you can start.
Read the information in the box, then answer the questions below. You have learned about measuring the densities of liquids such as water or solids. Such as wood, you can measure the volume and mass of an object and calculate the density using the equation density equals mass over volume. How do you measure the density of something much bigger, like a planet? The first person to measure the density of the Earth was a scientist called Henry Cavendish in in sep- uh,
1798.
1798. He was very shy and worked at home. He spent many hours doing experiments, hardly ever saw anyone else. He did lots of different experiments in chemistry and physics. He used Newton's law of gravitation to make the measurements to calculate the mass of the Earth. He used another scientist's measurement of volume of the Earth to calculate the density. The results that he got was 5.48 grams per cm cube. The measurement that the scientist made today is 5.513 grams per cm cube. Many centuries later, scientists wanted to know the density of things in space, such as stars and black holes. They used observations from telescopes all over the world to put a lot of measurements together to work out those densities. They worked out the density of the sun is 16.220 grams per cm cube.
Okay, thank you. Okay. Oh, before I forget, I have a lot of your books with me. I think I have your maths book and your physics workbook for some of y'all and all. So we are trying to give it back to y'all. But the thing is, when I collected your books just before the lockdown, I didn't manage to mark it because I think like 1-2 days after I collected your physics book, it was locked down already. So when we give you back your books will probably not be marked. So I apologize for that because I didn't know that it was going to take so long to be at home. But you will get back your books, or at least the school is trying to give you back your books so that you can revise. I don't know whose book, like who and what book is with me, because I know some of y'all, one day before the lockdown, y'all came to school, and I think it was 5 of y'all who got back your workbooks.
Yeah, teacher.
Yeah, and then the rest of y'all didn't come. So
sure.
so those who I don't know who got what book. So but then we've already sorted it all out in school. So I'm not sure when y'all will get it back, but we are trying to give it back to you. So just be aware that it's not marked yet. Because yeah, I didn't have time to mark it because it was quite soon after when they announced the lockdown. Okay. Okay. Let's look at these questions. Yeah, just give me a moment. This is 8.10. Okay, so if you look at the textbook 8.10, it talks about Al-Biruni, a Muslim scientist and a mathematician who wrote books on a lot of astronomy, geography, and everything. So we're supposed to compare Henry Cavendish and Al-Biruni. So in what way or ways was Henry Cavendish like Al-Biruni? Yeah. Okay, so Henry Cavendish is like Al-Biruni because he spent a lot of time doing experiments and he was interested in calculating density. So both of them spent a lot of time doing experiments and they were interested in calculating density.
Sure, I wrote they were both trying to find out the densities of different objects.
Yeah, same.
10. Okay. Okay, next one. In what way or ways was Henry Cavendish not like Al-Biruni?
So I wrote Cavendish wanted to find the density of the Earth, whereas Al-Biruni wanted to find the density of gemstones.
Okay, Ken? Correct. So Al-Biruni was doing on density of gemstones, Cavendish was doing density of the Earth. Okay, next. Give one reason why the measurement of the density of the Earth that scientists have measured today is different from Cavendish measurement. Why?
I wrote sir, it's because technology has improved and become much more developed.
Okay, so you
Yeah,
want
I wrote we have more advanced technology to understand the mass and volume of the Earth.
correct. So basically scientists today, they have more observations, they have better technology, and they can make a much more accurate measurement compared to the scientists before. Okay. Is today's measurement more or less precise than Cavendish measurement?
More.
More precise, again, because of the technology. Explain your answer. Because they have more information available to make accurate calculation compared to Cavendish due to the technology and everything. Okay. How were the methods for working out the density of the sun different from the way that Cavendish worked?
Sure, I wrote Henry used the theories and ideas of others, whereas the scientists didn't.
So I wrote the scientists that measured the sun used observations from telescopes all over the world to work out the sun's density, whereas Cavendish didn't.
Correct. So for the sun, right, scientists used telescopes to make observations about the sun. And a lot of scientists were involved in it. A lot of telescopes placed at different parts of the world. From that, information was gathered, and then they calculated the density. Whereas Cavendish, he worked alone. He came up, he worked alone, and he tried to figure out the density of the Earth by himself. So that's the difference. Kenyon has any questions so far? All following?
Yeah. So question E is what? More, right?
question E, as
Yeah,
in the last part.
yeah.
Okay. How much more dense is the sun than the earth? Choose one of these and
Oh, no,
circle.
no, no. Not question 1E. In today's measurement is more or less accurate than Cavendish measurement.
More.
More, right? Okay.
Teacher, will we discuss the physics light relation paper later?
Yeah. After we finish workbook question.
Okay.
Okay. Let's look at
Chair,
someone asked in the group chat, why is it more? Is today's measurement more or less accurate? More accurate. Why? Because we have more technology, better technology, which will help us make accurate measurements. Compared to last time, the sources are very limited. When it comes to science experiments and facts, you want to gather as much evidence, as much data to be able to prove a theory, to be able to prove a calculation. The more the evidence, the more sound the theory is, the more valid the theory is. Because when it comes to science, they want facts. It's about proofs. It's about whether you can see it or not. Okay, was it Jared who asked?
Chair, will we be learning the laws of cosines and sines this year?
Give me a moment, let me check. Definitely not this term.
Jared, that's the one you told me about yesterday, right? You use the length to find the angle.
Yeah, but it's quite hard, the formula also.
Did later when you come back to school teach me?
We won't
Okay,
learn it
I'll
this
try.
term. We won't learn sine and cosine this term.
So sine and cosine is all like trigonometry, right?
Yes.
Yeah, I learned it once. It was quite complicated.
Yeah, we won't be learning it.
When will we do trigonometry? Yeah.
I think when you go to Neftali.
Oh, okay.
Okay, let's continue. The last one. Yeah. Okay. A student is playing, I'm at page 81 by the way. A student is playing with a mass that is connected to the end of a spring. He pulls the mass down and lets it go. It goes up and down. The time it takes for the mass to go up and down is called the period. Here is his plan. Jared, you raised your hand. No, okay. I have decided to change the mass on the end of the spring. I will make the mass bigger and measure the time. I will put my results in a table like this. So different masses and then what is the time taken to go up and down. What is wrong with the table?
It does not have the measurement units.
Correct. So when you draw a table, there must be units. So he has written mass and time, but he did not write gram, kilograms, second, minute. So what is wrong with the table? 1A, he has not included the units. Okay, next one. Make a list of improvements that he could make that would improve the data he collects. What are some things that someone can do for this experiment to improve the data that is collected, to improve the results?
The type of spring must be the same and add the units to the table.
Okay, so you want to make sure the types of spring is the same. You want to make sure the type of weight is the same. Another thing is you want to repeat the experiment. So when you repeat the experiment, like I said just now, when it comes to science theory, conclusions and all, you must have evidence. So just because you do the experiment once doesn't mean that that is a sound evidence. What if another person repeats the experiment or does the experiment but it's different? So you have to repeat experiments in order to get an accurate result. All the, if let's say all the readings are different, then you calculate an average. Yes,
So we're doing A now, right?
B.
Okay. So for A, is it okay if I wrote there should be more categories for time and add another category for average time for more reliable results?
Yeah, can.
Yeah.
But then that means 1B, you must say repeat the experiment in order to get
I
average
wrote that
time.
already.
Okay, C, you have been given the following equipment: a box of springs of different length, 10 100-gram masses, a stopwatch. Plan an investigation to answer a different question from the one that the student was asking above. Write your plan in the box below. So you want to do a slightly different experiment asking a different question. So the question that this student asked was, how long it will take, the time it takes for the mass to go up and down. Okay, so for the different weights, how long does it take? What is the period? So now it says plan an investigation to answer a different question. And they've given you different length of spring, and then they've given you masses. So what is the question you're going to ask?
Yeah, I wrote if I add 100 grams of mass of weight to springs of different length, how far will the spring expand? Therefore, I wrote in other words, how does the weight of an object affect the expansion of springs at different lengths?
Yes. So now I have box of different length of spring. That means that is my manipulated variable. That is what I'm changing. And then I have mass. So basically, how does the mass affect, how does the spring, the different length of spring affect the time taken when masses are put are hung to it. So let's say I put 100-gram mass, okay, to a short spring, and then I pull it and let go. Then I record the time, and then I use another length, maybe a slightly longer spring, and then I do the same thing and see does it take longer or shorter. So in this case, what is manipulated is the different lengths of spring. Okay.
Sure, my question is, will the length of the spring affect the period? Is it okay?
Yeah, can.
So I wrote the apparatus and I drew a model also.
Can you send a picture?
Okay.
You send to my send to the group also can.
I just send. I send it to the group. Get it done.
Okay. Yeah. 3 10-gram masses, meter ruler to measure. Yeah, that's good.
Get it?
Yeah. Okay. Anyone has any questions?
No, sir.
Okay, so I'll just repeat question C. Okay. So basically the question is, how does the length of different springs affect the period? Where period here is the time taken for the mass to go up and down. Okay, so that's the question that we want to investigate.
Sure, for question 1B, is it okay if I put do preliminary work?
Sorry, can you repeat that, please?
Sure, for question 1B, can I write do preliminary work?
Let me see. Let me read the question again. Like a list of improvements that he could make that would improve the data collect. What would be some examples of preliminary work? Like what would you, because you got to be a bit specific if you say that.
Check the apparatus whether it's working properly or not.
So I
Yeah,
put he does some research on secondary data before he starts his experiment.
Ken? Jared also can. Both can. Okay. All okay? Okay. So it is 9:45. Okay, y'all can go and take a quick break and then we'll come back and do the light questions. Okay? Come back at, now it's 9:45. Come back in 10 minutes. Okay? I'll see y'all in a bit. Okay, let's continue. Before we go to the worksheet, let's just recap a bit on light, okay? Okay, so yeah, we'll just recap a bit on light. Can you see the slides on the screen?
Yes, sir, can see.
Yes, sure.
Yes, sure.
Okay. Now, okay, everyone take out your physics book, exercise book. Before we start, I'm going to read out a few words and you all have to write it out, okay? I'm going to stop.
Sure.
Sorry,
Sure.
please repeat.
Sure, I don't have my exercise book, it's with you, so I'm writing it down on a piece of paper, can I, Sure?
Can. Okay, so I'm going to say out 10 words. Okay, there are 10 words. Basically, it's like spelling lah. I want you all to know the spelling of these 10 words. So I will test it out first, okay? So, okay, number 1, transparent. Okay, write down transparent. Then later I will show you the words and then you see whether correct spelling or not. Number 1, transparent. These are words in light that you must be able to spell correctly, must be able to mention in your answers if the questions require you to do so. Number 1, transparent. Number 2, opaque. Number 2, opaque. Number 3, reflection. Number 4, incident. Number 5, converging. Converging. Number 6, photoreceptor.
A what?
Photoreceptor. Number 6 is photoreceptor. Number 7, dispersion.
So can you repeat number 5 and 6 again?
Number 5, converging. Number 6, photoreceptor. Number 7, dispersion. Number 8, spectrum. Number 9, translucent. And number 10, vacuum.
So number 10,
Vacuum.
vacuum.
Okay, I'll repeat number 1 to 10. Transparent, opaque, reflection, incident, converging, photoreceptor, dispersion, spectrum, translucent, and vacuum. Okay, let's look at the spelling of each one of them. Okay, check your spelling. Okay, anyone got any
The
of it?
photoreceptor, I wrote it as 2 words.
Oh, okay, it's one word.
So vacuum has 2 U's.
Yes.
Teacher,
Okay,
do I mark my words?
yeah, you can. And
Thank
you
you.
correct if got any mistake. Okay, all okay? Okay, let's continue.
Yes.
Okay, everything you see has a connection to the sun. Okay, everything was brought to this classroom by humans who rely on plants to provide energy. Plants get their energy from the sun. Okay, so understanding the characteristics of light, we're going to recall the difference between luminous and non-luminous objects, identify materials that transmit different levels of light, and describe light travel. Okay, light is emitted by certain objects. The light then reflects or bounces off another object and is absorbed by our eyes. Because that's how light works. It is emitted, given off by certain objects, and then that light reflects off another object, and then it gets absorbed by our eyes. That's how we're able to see objects. So if you look at the picture, the light is given off by the lamp. Okay, then it bounces off the book, and then it's absorbed into our eyes. That's how we're able to read what's in the book. Okay. Light travels in waves. It travels in straight lines. And the speed of light is 3 times 10 to the power of 8. Okay. Okay, difference between luminous and non-luminous object. An object that gives out light is described as luminous. So luminous objects emit, they give out light. An object that does not give out light is non-luminous. So the comb is a non-luminous object, it just reflects, but it's not a source of light. Okay? So if I were to sort out these things in luminous and non-luminous into a table, okay, can you quickly sort it out? Draw a table and then sort out all these things under luminous and non-luminous. I give you all 3 minutes to do it.
That,
Done?
yeah,
Okay, who's still doing? Raise your hand.
Done.
All done. Okay, let's see. Okay, check your work.
Sure, there's mobile phone 2 times.
Oh yeah,
there was an
just one side?
electronic whiteboard actually.
Let's see. Oh yeah, don't know where they got the electrical whiteboard from. Let me just edit it.
Teacher, the star and paper.
Okay, so star will come under
Non.
luminous or non-luminous?
Non.
Non.
Paper also non.
Correct. Oh, is there paper here? Got a sheet of paper.
Oh.
Okay?
Okay.
Okay. Okay, so never mind. Okay, then we look at transparent, translucent, and opaque objects. Okay. What is the difference between all these three? Can anyone tell me? How is opaque objects different from transparent objects?
Opaque objects does not
Light
light
cannot
in
pass
at
through
all. Transparent
an
allows
object.
light to go in.
Okay.
Translucent only allows a bit of light to go in.
Okay. So opaque does not allow light to go in at all, pass through. Transparent allows light to pass through. Translucent is in between transparent and opaque, a little bit. Okay. So my opaque objects, transparent and translucent objects.
So what about that question? So why is it that you can't see the bottom of the ocean thing?
Which one?
The one, the black.
We'll look
Why?
at it. We'll look at it now. Okay. Why is it so dark at the bottom of the ocean, but water is transparent?
So because the lower you go, the less light there is.
Okay, so if we look at this, I have the sea level 200 meters and 1000 meters below. So the first part, the euphotic zone, sunlight rarely penetrates beyond the zone. So the sunlight cannot pass through beyond, hardly. Okay, sunlight decreases rapidly with depth. This is a dysphotic zone. Photosynthesis is not possible here. And then the midnight zone, aphotic zone, sunlight does not penetrate at all. This zone is bathed in darkness.
Should you dare to dive in the midnight zone at night alone?
Sorry?
Would you dare to dive in the midnight zone alone at night?
Yes.
Alone. You ask me if I dare do it alone. Alone,
Yeah,
no.
at night.
Alone, no. I don't think they allow you to dive alone also. Usually when you go
Yeah.
diving, they won't
See,
allow you.
even if I go with a group of people at night, I won't go diving at night.
I plan to do my license for midnight diving. I just haven't done it yet.
But do you have your normal diving license?
Yeah, normal diving license got.
So you need a separate license to go night diving also.
Correct. Because night you have to take more precaution. There are different species of animals that you need to look out for. And then the thing with diving is the lower you go, the lesser time you can spend there.
Yeah.
So all these things must be taken into account. So that's why you have to take a separate diving license for that.
So when you go diving, do you feel? I don't feel the depth anymore, When you go diving, you don't notice how deep you are in the water already.
Yeah, you don't
Does
notice.
it happen to you?
Correct.
Yeah.
Okay. The water surface reflects some of the light, while the remaining photons that do penetrate the air or water surface begin to refract. Okay, they begin to bend and scatter, and then they're eventually absorbed by the opaque particles suspended in the water. That's why it's very dark at the bottom. Light cannot pass through in a straight line in the ocean.
So can we copy that?
Yeah, I think you should copy this down. So you write the question, why is it dark at the bottom of the ocean, but water is transparent? You write that question down and then write this explanation.
Sir, what are photons, sir?
Photons is the how do I explain it? In simpler terms, wait. It's the particle that the light emits. So there's the sunlight or whatever light source, when it emits the light, photons is the particles that is emitted. Yeah, light particles.
Okay, sir.
Teacher, I got a question.
Yes?
Regarding to like our work, teacher, the worksheets that you give us, right? Do we print it out, or when we do after that, can we put it in our file?
Can.
Since we don't have our exercise books.
Can.
Okay, teacher.
Yeah.
Yes?
So you know when you go diving, right, Jennifer, if you go to the surface too fast, nitrogen bubbles form in your brain, right? Is there like any precautions you can take? Like if that does happen, is there like some sort of breathing techniques for you to release the nitrogen bubbles and stuff?
Yeah. Usually,
Oh.
first you get scolded by the trainer, and then he will tell you what to do lah. But you will
That
feel
happened to you?
no, because I was no lah. I made sure I did the right thing lah. But sometimes when you're diving, right, and you're below water and then you panic, suddenly people tend to like surface up very quickly. So
Yeah. Like when I
sometimes
went
it
like
happens
for this
lah.
like diving thing, the lady said don't panic when you're under the water.
Mm.
So why does the question say absorbed by opaque particles?
Sorry, where? And are eventually absorbed by opaque particles suspended in the water. Opaque particles means like for example rocks or sediments that are opaque in the water.
Oh, okay.
Mm. Anyone here been for diving before?
Malcolm and I have gone.
Where, Malacca?
Sorry, Je?
Where?
Malcolm and I have gone.
Oh, Malcolm. Where
Yeah,
y'all went
just
diving?
in like this super deep pool. It was just like a beginner's thing lah.
Oh,
It was just before the lockdown.
y'all have a nice time?
Yeah, it was very fun underwater.
That's good. Okay, who's still copying? Please raise your hand. Okay, let's continue then. Oh, still copying, okay.
Cher, what is the most dangerous species of animal you ever seen in the water, Cher?
Um, most what dangerous ah?
Yes.
Dangerous ah? I don't know. Is a stingray considered dangerous?
Yeah.
Yeah.
I think stingray lah.
See, if animals try to attack you in the water, do they give you like a spear gun or something?
No lah.
So will the animals try to attack?
Wow.
or they just swim away?
It depends on what we do in the water. If we just swim by ourselves, they will just swim and pass through. If we start disturbing them, then they will try to attack lah, because that is their defense. Actually, they attack you not because they trying to fight with you. That is their defense mechanism, because they want to survive. So that's why they attack you, not because they have something against you.
So have you seen a shark?
No, I've not seen a shark. When I went diving, when I went to do my license, so in my group there are 4 of us that learned it together. So when we were diving, and then my so there were 4 of us, 2 guys and 2 girls in our group. So the 2 guys saw the shark, but I didn't see the shark, because by the time I turned, the shark went away already. So I didn't see.
So apparently when you say when you're diving with sharks, actually, you shouldn't like linger at the top and like move around your chair. You should just take your stuff and just go to the bottom.
Yeah, correct.
So what?
Sharks also, they get attracted to blood.
Movement.
As long as they don't smell blood, they're okay, and as long as you don't disturb them lah.
If you accidentally cut yourself while under the water and the sharks swimming around you,
Yeah, if they can smell the blood, they will come towards you lah.
Sure, they can smell, they can sense the blood.
Yes.
yeah, from like you're not saying like 20 kilometers away or something like that, right? Chad?
Yeah, they are quite good at it. Like they can sense it quite fast.
So if they sense blood, then they come and attack you.
Correct. They'll come to you lah.
Or they try to eat you.
If they're hungry lah, I guess. If they don't want to eat you also, maybe they attack lah. If they feel threatened. All animals are like that. When they feel threatened, they attack. They
So
don't.
what do you have a license in, like other than diving?
What license do I have? I have driving license lah.
Oh,
Driving license, diving license. The next one is to do night dive license. What else do we need license for?
Guns.
Huh?
Guns.
Guns. Okay, I don't think I will need license for guns all. What else? My uncle got like I'm sure there are some
Skydiving.
uncles. I'm sure you all also have some uncles who hunt and all that kind of stuff. I have an uncle who hunts, so he has a gun in his house.
Oh,
so they need license for that also, right, Chel?
Yeah, he needs
yeah.
license to hunt.
In Malaysia, it's very hard to maintain the license.
Yeah, my uncle, because his father was a hunter, and then at that time lah, those days it was not difficult because they were all hunters. So yeah, just wait a moment 1 second.
I ring my doorbell. I think the aircon guy is here, ma. Heard the doorbell. Never mind.
I think teacher's doorbell rang.
Can I get a higher? Answer.
What?
What?
Can I get a Hoya?
Yeah, I'm not saying that.
Guess what? Watermelon Sugar music video just came out and I wanna die.
Okay, so why? What happened? Okay, let's continue. Okay, so that's pretty much it for this part. So let's look at the questions. Okay, can you all see the questions on the screen?
Yes, Chel. Do we mark?
Yes, you can. Okay. So, a ray of light passes through a length of a curved optical fiber. Draw a diagram showing the fiber and the path of the ray of light. So, this one is, you can find a picture on in your textbook. Page 123, 123.
So I drew an optical fiber and then I draw straight lines of the light hitting
But you must show total internal
the
reflection.
optical fiber.
You must show total internal reflection because optical fibers, they work using total internal reflection. So, okay, let's see. I draw, let me try drawing now. Okay, so, oh no, wait. Okay, so let's say I have a cable. Okay, so what you must do is you must show that total internal reflection is happening. Because optical fibers work by total internal reflection, and you must show the arrow of the light ray as well. Okay?
Cher, have you ever seen
Take a photo and send me.
Ken. Sorry, what, Jared?
have you ever seen an endoscope in use before?
Endoscope in use? No, I never.
Yeah.
I've never used an endoscope before. Has an
Okay.
endoscope gone into my body before? Yes. But I've never used, as in like the doctor has put an endoscope into my body before, yes, but I've never seen an endoscope before. Like as in I've never used one.
Oh, okay, Cher.
Yeah, when you take endoscope, like you can't eat, right? For like the night, you have to fast.
Correct, because because if you have food, then it's difficult for the endoscope to pass through. Have you sent it to me, Isabel?
Just sending to.
Oh, okay.
Yeah.
Yes.
Can you stop share for a while? I can't get back to full screen for some reason.
Stop what?
Stop the share for a while, Joe. I can't get back to my. Okay, Joe, again.
Now can see?
Just send already.
Yeah.
Okay. You
So,
sent.
so I have a question related to the textbook lecture. You know, on page 119,
Mm-hmm.
you know, they conduct an experiment with the angle of incident and angle of refraction.
Mm-hmm.
Why isn't the angle of incidence equal to the angle of refraction? It's like 10, 12, 30, 29. Oh, why isn't it equal?
Because sometimes they never make it accurate. Like maybe there's some sort of error in the experiment.
Oh,
Mm.
but then how do you make sure that there's no there's no errors in the experiment when it comes to light?
Have to make sure that the surface is completely like super smooth. And then usually what they do is, let's say you take, like now they have 12, 29, 51, 68. They do a few experiments and then they calculate the average. Then usually you should get the same thing lah.
Okay.
That's the thing with experiments, even with smooth surfaces. If you can remember what I said before last time, that even with smooth surfaces, it's never 100% smooth. There is an uneven surface even in that smoothness, which is
Yeah.
why it will affect the reading.
Okay, Joe.
Isabel, yeah, Ken, your answer correct. Okay, Describe one use of optical fibers in medicine. You may draw a diagram to help you with it. So one use of optical fibers.
Endoscope.
So you have to describe it. So you have to explain it.
Jared, you
So
can
is
use
my
optical
drawing
fibers.
also okay? Like my diagram I drew.
Yeah, can.
Yeah.
Elijah, what is it? Yeah.
I wrote you can use optical fibers as endoscopes. Light is sent down one bundle of optical fibers and shines on a structure inside the body. Another bundle of optical fibers transmits the light reflected from the inside of the body to a camera so the doctor can see an image and diagnose the problem.
Correct. So you
Sure,
have
I wrote optical fibers are also in endoscopes. When endoscopy process is being conducted, the endoscope is a flexible tube with tiny cameras and light attached to it. It is made up of optical fibers.
can. Okay. Anyone has any other answers? No. Okay. Let's move on. Draw a straight line from each wave on the left to the most appropriate speed. So light in air. Light in air is?
3 times 10 to the power of 8.
Yeah. 3 times 10 to the power 8 here. And
So
then,
microwaves in a vacuum is also the same, right?
correct. Also 3 times 10 to the power of 8. Sound in steel?
1 times 10 to the power of 5.
No, not quite.
6,000 meters per
6,000
second.
ms.
Yeah. 6,000 meter per second. Okay. So light in air will be here. Microwaves in vacuum is also here. And then sound in steel is here. Okay. Okay. Next. The refractive index of a block of glass is 1.5. Use your value for the speed of light from B to calculate the speed of light in this block. So if you were to look at your textbook, or if you can remember, refractive index is speed of light in vacuum over speed of light in the medium. So refractive index is 1.5. So I just use the formula. Let me just write it up. So 1.5 is equals to speed of light in vacuum, which is from B, we know that it's 3 times 10 to the power of 8, and then divided by the speed of light in the block, which we don't know, which we want to find out. So to find X, you bring X here and you bring 1.5 down. So X is equals to 3 times 10 to the power of 8 divided by 1.5. What do you all get?
I got like some 0.000000000.
You should get 2 times 10 to the power of 8. 2 with 8 zeros.
Yeah, that's what I mean.
Yeah. So you should get 2 times 10 to the power of 8 meter per second. Everyone got that? Anyone don't know how to do?
Sure, I got a different answer.
What did you get?
I got 15 only.
15 what?
I only got 15 meter per second.
How did you get 15? Okay, let me explain. So refractive index, there's a formula for it. Okay, so now refractive index is equals to speed of light in vacuum. Okay, let me write here. This is the formula that was given, which we looked at in school. Refractive index is speed of light in vacuum divided by speed of light in the medium, whatever medium we are looking at. So now it says calculate the speed of light in the block. That means now the medium is the block lah. So we want to calculate this. So we are given refractive index is 1.5. And then the speed of light from the previous question, we saw it was 3 times 10 to the power of 8. And then we want to find the speed in the medium. So to find x, we take 3 times 10 to the power of 8 divided by 1.5. I bring this up and I bring the 1.5 down. So 3 times 10 to the power of 8 divided by 1.5. And if you plug that in your calculator, you'll get 2 with 8 zeros. That means you write it as 2 times 10 to the power of 8, because 8 zeros, meter per second.
So can you give me some time to copy that?
Can. Pooja can understand? Pooja can understand or not?
Teacher, the SV is speed of light in vacuum,
Yes.
and then SM is speed of
Light
light.
medium. This is on page 121 of your textbook if you want to refer.
So if we are finding for the speed of light in vacuum, and then we are only given the refractive index and the speed of light in medium, then we just change it the other way around, right? Use the same formula, right?
Yeah, so you times it lah, refractive index times the speed of light in medium. But speed of light in vacuum is always constant, it's always the same.
So when we count, do we have to times the 10 power of 8, or we can just leave the answer like that in the exam?
I would say put it like this, times 10 to the power of 8. Because this is a scientific way of writing it. If it's 7 zeros means 10 to the power of 7. If 9 zeros means 10 to the power of 9.
Okay, teacher, done.
Okay. Let's move on. Okay. Explain what is meant by total internal reflection. Anyone wants to try?
Sorry, Chair.
Anyone wants to try what is meant by total
Can I
internal?
try?
Can.
I wrote total internal reflection is a complete reflection of a ray of light within a medium such as glass or water.
Okay. Anyone else?
Yeah, Chair. I wrote when the angle of incidence is larger than the critical angle, total internal reflection takes place. All the light is reflected into the medium that the light source came from.
Yes, can.
So the answer is correct, right? So
Yeah.
So can I go to the toilet?
Can.
Thanks.
Okay, what is meant by critical angle? Critical angle refers to the angle of incidence when the angle of refraction reaches 90 degrees. I repeat, critical angle is the angle of incidence when the angle of refraction reaches 90 degrees.
Sure, when the reflected ray is 90 degrees from the normal, the critical angle is the angle of incidence when the reflected ray is 90 degrees from the normal.
10. Okay, figure 7.1 shows a ray of light traveling in air, incident on a glass prism. The speed of light in air is 3 times 10 to the power of 8. The speed of glass is 2 times 10 to the power of 8. Calculate the refractive index. Again, use the formula from before. So refractive index is equals to speed of light in vacuum, which is 3 times 10 to the power of 8. Now divided by speed of
So
light.
will this kind of question come out in like maths also, or it's just for physics?
Physics only lah, usually.
So I got the refractive index is 1.5.
Get 1.5. Yep. So you just divide both of that. Okay. Everyone okay so far? Anyone confused?
Yeah, I'm confused with this part.
So just says calculate the refractive index. So from the formula before, refractive index is equals to angle of incidence. Sorry, not angle of incidence. Speed of light in air, which is 3 times 10 to the power of 8, divided by speed of light in the medium. In this case, they have given you the speed of light in the medium. Just now they gave you refractive index, asked you to find speed of light in the medium. Now they've given you speed of light in medium and ask you to find the refractive index. So you just take this divided by this, and you should get 1.5. All okay so far?
Yeah, Chair.
So your answer is 1.5, right?
Yes.
Done. Sir. So do we have to take a photo of this and send it to you later when we put it in Enmodo?
And no need.
Okay, sure.
Okay, next. Show that the critical angle for the glass air boundary is 42 degrees Celsius. 42 degrees.
So this one I didn't do, Chair. I don't know how to do this.
Okay, this is something I don't know if I don't think I taught y'all, but let me show you all how to do it. Okay, so there's a formula where sine of the critical angle, C is critical angle, is equal to 1 over the refractive index.
Just sign as in the sign in the calculator.
Yes. So sine
Like
of the critical angle is equal
sine times C, Chair.
no, sine of the angle. So if you were to put in your calculator sine, it will automatically open a bracket.
Oh.
So sine C is sine 42.
No, so you want to show that it's 42. So what you do is you take sine C, you you put C there, is equals to
So can I repeat?
1 over. So sine, this is the formula, sine C, where C is the critical angle. So sine of the critical angle is 1 over the refractive index. So I want to show that C is 42. So what I do is I take 1 over, the refractive index is 1.5. So sine C is equals to 1 over 1.5. So when you calculate 1 divide 1.5, it is 2 over 3.
Then bring it
And then
inverse.
sine C is 2 over 3. And then to calculate C, you shift sign.
Inverse sine.
You inverse sine, correct. So C is equals to sine inverse 2 over 3.
So what is sine minus 1, 2
That
over
means
3?
inverse. That
So
means,
must we always round it up to the
okay, wait, one by one. Sines, okay, I go back again. Sine, this is a formula. Sine of the critical angle is 1 over the refractive index. I want to show that C is 42. That's what the question is. So I want to show that the critical angle is 42. So I take 1 over, the refractive index is 1.5. So sine of the critical angle is 1 over 1.5, which is 2 over 3. Then to calculate C, because that's what we want to find, I take inverse. I bring the sine over to this side. It's like maths, like bringing over the sine, you're bringing over whatever you don't want to the other side. So when you bring sine over to the other
So
side,
what is this?
it becomes inverse sine. Wait, when you bring sine over to the other side, it becomes inverse sine.
Inverse sine.
Yes. So how you do inverse sine in your calculator? You click shift at the top left, shift, and then you click sine. Then your your calculator will say sine -1. Can you all see that?
Yeah.
And then you plug in 2 over 3. And then you close bracket.
So I got the answer is 41.81. Then I round it up to the whole number is 42.
So you write here 41.81 degrees. And then you write 42.
Degrees. Actually.
Yeah.
Oh yeah,
Angle.
angle. Yeah.
42.
Will this
Shall
come
I
out for
pose the
exam?
question? No,
So
this
what is this? So what is this log holder?
log. Log is
What is
another.
it? No, what is this log called?
Oh, this law. Oh, this is the formula to calculate critical angle. C is critical angle.
So these questions come in exam.
Sorry?
Well, like these questions come in exam.
This one, no. This
So
part,
you don't have to memorize this
no.
method. Huh?
Okay, let's look at the next one. On figure 7.1, draw carefully without calculation the continuation of the ray through the prism and into the air. So basically, what happens is, anyone wants to try this one?
Yeah, sir.
So I did. I don't know how to do this.
So I drawn the thing, okay?
Yeah.
So we must draw the
I did
triangle.
this.
You have to draw the light ray.
So I drew it slightly outwards because it's going from a denser medium to a less dense medium.
Okay.
So refraction takes place. So it moves away from the normal.
Okay.
So it's like I wrote this. How do you write this?
Okay.
Wrong.
So you have it right, but it's just that you have to draw this one inside, and then it hits down, and then it goes sideways. So the light ray passes into the prism.
Oh, it has to hit.
Hit inside.
Yeah, but if it goes inside like that, right? Doesn't that mean it doesn't that mean it has to move, the direction has to change because of refraction?
Just a moment.
So can you draw?
Wait, 1 second. I'm just trying to get my mouse to work. Okay. I think I better show like this now. Okay. Can you see me on Google?
Yes, sure.
Can? Okay. Mm. See a diagram, a clear diagram for you all to see so that I can explain. Okay. I think there's a error with the picture. And there's an error with the angles here. Okay, let me just double check this question and then I'll get back to you. I think there's an error with the diagram. Okay, I'll get back to you all on this, Okay. Okay.
So, are we going to go to the circle theorem worksheet today?
No, not today, but then I will talk a bit about it. Let's look at question 4.
So it means after this you're going to talk about the circle theorem thing.
Yeah, I just want to highlight some things
Okay.
about it.
So if we're done, then we take a picture and send.
For which one?
Circle theorem.
You submit it on Edmodo.
Okay, sure.
Okay, the refractive index of glass in air is 1.5. State the equation that relates speed of light in air, speed of light in glass, and n. So that is the formula from just now. So I just write n. So n is for refractive index. So n equals to speed of light in air divided by speed of light in glass.
So the answer is the same as the first one, Chair. For I think for 2.
But you use this one.
Yeah, Chair, I use that.
Okay, so calculate the speed of light in glass. So same thing here, use the formula. The refractive index is 1.5. So that means this is 1.5. So you take 1.5
So
equals to,
question, so you're not doing question number 3?
no,
Oh,
1, 2,
okay.
and 4 only. I told you all to do 1, 2, and 4 only. Because the 3 all I haven't taught you all yet. Divided by speed of light in glass. And then it's same like the previous question. Now you bring this up, you bring this down, and then you should get your answer to be 2 times 10 to the power of 8. Okay? Everyone okay so far? Okay. Light traveling in glass strikes the edge of the glass. Figure 6.1 shows a ray of light at an angle of 41 degrees to the normal. The light passes from the glass into the air, so denser going to less dense. Okay, calculate the angle that the ray makes with the normal in the air.
Yeah, Chair, I didn't know how to do this. So is there like a formula for this?
Yes, there is a formula for this as well. Again, I've not, you all will learn this next year, but I will just teach you all. Okay. So I have, this is the other formula. Refractive index is equals to sine I. I is incident angle, angle of incidence, divided by sine R, angle of refraction. This is the formula. So you put 1.5 in here because that's the refractive index. My angle of incidence is 41. So sine 41 divided by sine R, because they're asking for the angle of refraction, which is the angle that ray makes with the normal and in the air. And then
Can you repeat your what sign and what?
So this is the formula. N equals to sine I over sine R. N is the refractive index. I is angle of incidence. R is angle of refraction. So angle of incidence is 41. Refractive index is 1.5. Calculate R, because they're asking for the angle that the ray makes with the normal in the air. That means if I have the refracted angle, this one lah, they're asking for this one, which is angle of refraction. And then, like again, normal maths, I bring this up, bring this down. So now sine R is at the top, equals to sine 41 divided by 1.5. If you calculate this in your calculator, sine 41 close bracket divided by 1.5. Then you'll get a lot of numbers, and then you shift sign the answer. Because you have to bring, because R is equals to the inverse of sine. The answer that you get when you took sine 41 divided by 1.5. So you get 25.94. Stop at 9 lah. 25.9 degrees or 26 degrees.
Sure, done, sure.
So you get 25.93, yeah?
Can. Okay. State what happens to the light that strikes the edge of the glass at an angle to the normal much larger than 41. When it's larger than 41, what happens? When the angle of incidence is larger than the...
It will move further away from the normal.
No. What happens when, so when let's say it's bigger than 41. Okay, so bigger, it says bigger, right? Larger than 41. So it means it's going this way. So what happens?
You go away from the normal actually.
Okay,
And
and
then
what happens?
eventually become a critical angle.
Correct, which means what will happen? What reflection will happen?
Total internal
To-
reflection.
Correct. So, total internal reflection will take place. Okay, and the last one example of how optical fibers are used in medicine. This is similar to the one previously. Similar answer to question 1A2. Okay, anyone has any questions?
No, sir. Are we going to do the maths thing now?
No, I just wanted to highlight on circle theorems. Okay, so okay, so what I wanted to say is, when it comes to circle theorems, you all have to figure out the rule by yourself. Okay, the question won't say, okay, applying this rule, what happens? Applying, so you have to look at the circle very carefully. Put your 6 or 7 rules, I think, that we learned. Put it beside you, list them down one by one, put it at the side. Now look at the circle diagram and see, okay, which rule can I apply for this question? And one question, sometimes there are more than one rules that you apply, most of the times. More than one rule you apply to find the different angles. Okay, so you have to, like I said in the previous class as well, you have to practice on it. The more you practice, the more you see, you're able to be alert to the rules that are used in the circle, angles in circles question.
Sure, we have to remember these formulas in the exam, right?
Yes, you have to remember the rules in order for you to figure it.
How would we do our workings all online?
So far they have told us to only come up with objective questions.
Oh, okay.
So yeah, that's what the plan is for now, lah.
Hmm.
Okay, so you have to figure out the rules. I cannot tell you what the rule is. I cannot tell you which theorem to apply. You have to look at the circle and be like, okay, what is the rule that can be applied to this circle? Okay, based on this rule, okay, what angle is this? What's the angle of that? What's that? You have to calculate by yourself.
Sure.
Yes.
In exams, can we use the laws of sines and cosines in
If
exam?
it's going to help you get the answer, then fine lah, since it's objective questions.
Oh, okay, sure.
Okay, we will talk more about it on Friday when we have our maths class lah. Okay. Okay, that is all for today. Okay, any questions, anyone? No questions. Okay, then I'll see you all on Thursday for study skills.
Okay, sir.
Okay, thank you.
Bye.
Bye.
Okay, sir.
Bye,
Bye.
teacher. Good night.
Bye, sir.
Bye. Bye.